Your eye color isn't just genetics rolling the dice, it's a biological signature that reveals where your ancestors lived, what threats they faced, and how their bodies adapted to survive. Right now, looking at someone's eyes, you're seeing thousands of years of evolutionary pressure compressed into a single physical trait, and the science behind it is far stranger than most people realize. Let's break this down, because what you think you know about eye color is probably incomplete or just wrong. Brown eyes aren't the default. They're the original human armor. That rich, dark pigment saturating your iris isn't there for aesthetics. It's melanin, the same compound that protects your skin from ultraviolet damage, except in your eyes, it's doing something even more critical. It's shielding the delicate DNA inside your eye cells from direct radiation bombardment. Early humans didn't have sunglasses. They had melanin. And the deeper the pigment, the better the defense. Studies confirm that brown eyes absorb nearly 90% of incoming light, which means less UV penetration, less oxidative stress, and significantly lower risk of certain eye diseases over a lifetime. This is why populations near the equator overwhelmingly carry brown eyes. It wasn't a cultural preference, it was a survival filter. If your ancestors lived under intense year-round sunlight, lighter eyes would have been a liability. The UV exposure would have caused cumulative damage, reduced visual clarity, and increased the risk of conditions like cataracts and macular degeneration. But melanin does more than just block harm. It also optimizes performance in bright environments. Because melanin absorbs rather than scatters light, people with brown eyes experience less glare sensitivity. They can maintain sharper vision in direct sunlight without squinting or losing focus. This gave a functional advantage in open landscapes where detecting movement, tracking prey, or spotting danger required clear sight under brutal midday sun. Now here's where it gets interesting. Brown eyes don't actually change color, but they can appear to shift tone depending on lighting. In low light or candlelight, you might notice golden or amber highlights flickering across the iris. That's not pigment variation. That's physics. Light is refracting through the layered structure of the eye, revealing depth that isn't visible under normal conditions. It's the same principle that makes certain gemstones appear to glow from within when you change the angle. Your eye is doing that naturally. But if brown eyes are the biological standard, how did we end up with blue? Blue eyes are the result of a single genetic glitch that occurred between 6,000 and 10,000 years ago. Before that moment, every human on the planet had brown eyes. Then one person, somewhere near the Black Sea region, experienced a mutation in a gene called OCA2. This mutation didn't add blue pigment, it turned off melanin production in the iris. Almost entirely, let me say that again, blue eyes contain no blue pigment, zero. What you're seeing is structural color, the same optical trick that makes the sky look blue. When light enters an eye with minimal melanin, shorter wavelengths in the blue spectrum scatter back out while longer wavelengths pass through. The result is that striking, icy blue appearance that can shift from bright to grayish depending on the lighting and surrounding colors. This mutation spread with shocking speed. In just a few thousand years, blue eyes went from a single individual to reaching frequencies as high as 80% in parts of northern Europe. That kind of rapid spread doesn't happen by accident. It suggests either a strong environmental advantage or intense sexual selection, possibly both. One theory centers on light availability. Northern Europe during the last ice age had long, dark winters with limited sunlight. Eyes with minimal melanin allow more photons to reach the retina, which could have provided a slight but meaningful advantage in low light conditions. Better twilight vision means better hunting, better threat detection, and better survival during months of near darkness. But there's another factor at play. Rarity creates attraction. Blue eyes were visually striking in a world where everyone had brown eyes. Some researchers believe that sexual selection, the preference for novel and distinctive traits, accelerated the spread of this mutation far faster than environmental pressure alone could explain. If people with blue eyes were considered more attractive and therefore had more offspring, the trait would proliferate rapidly, even without a direct survival benefit. Recent DNA analysis has turned old assumptions upside down. Scientists extracted genetic material from ancient European remains and found individuals with blue eyes and dark skin. This proves that light eye color evolved independently from skin lightening, dismantling the outdated idea that blue eyes were just a side effect of adapting to northern climates. The mutation for blue eyes came first, possibly thousands of years before pale skin became common in the same populations. Then there's gray. Gray eyes are even rarer than blue, appearing in less than 3% of people globally. They contain the absolute minimum amount of melanin, even less than blue eyes. But instead of reflecting a single wavelength range like blue, gray eyes scatter light across a broader spectrum. This creates that distinctive steel or silver appearance that can shift subtly between shades depending on the environment. Functionally, gray eyes likely represent an extreme adaptation to low-light environments. The minimal melanin allows maximum light entry, which would have been advantageous in overcast northern regions where sunlight was diffuse and indirect for much of the year. But this comes at a cost. People with gray eyes are highly vulnerable to UV damage and need to be more vigilant about sun protection than those with darker eyes. Culturally, gray eyes have been associated with emotional neutrality or detachment. Unlike brown or blue eyes, which shift tone noticeably with lighting and emotion, gray eyes maintain a stable, cool appearance. This makes micro-expressions harder to read, which some interpret as mystery or inscrutability. Whether this perception has any basis in personality or behavior is debatable, but the visual effect is real. Now we get to the rarest common eye color on the planet: green. Only about 2% of the global population has true green eyes, and the genetics behind them are absurdly complex. Green eyes require at least 16 different genes to align in a very specific way. Too much melanin and you get brown. Too little and you get blue. Green sits in a narrow middle zone where moderate melanin combines with a yellowish pigment called lipochrome. When light interacts with this precise mixture, it produces that unmistakable green hue. But green eyes are chemically unstable. They're highly reactive to environmental changes. Depending on lighting, clothing color, or even surrounding objects, green eyes can appear mossy, golden, hazel, or blue-gray within minutes. This dynamic quality isn't an illusion. It's a real optical phenomenon caused by how different wavelengths of light interact with varying pigment densities across the iris. Historically, this shifting appearance made green eyes a subject of folklore. In medieval Europe, they were sometimes linked to witchcraft or supernatural abilities. In Greek mythology, green eyes were thought to carry mystical powers. Even today, they're culturally associated with creativity, intuition, and mystery, though there's no scientific evidence linking eye color to personality traits. From an evolutionary perspective, green eyes likely provided adaptive flexibility. Their moderate melanin offers some UV protection while still allowing enhanced light sensitivity. This balance would have been useful in temperate climates with variable lighting, forests, mountains, or regions with seasonal changes in sunlight intensity. Green eyes are most common in people of Celtic and Germanic ancestry, particularly in Ireland and Scotland, where certain populations show frequencies as high as 86%. But they can appear in any ethnic group given the right genetic lottery. Then there's hazel, the ultimate chameleon. Hazel eyes genuinely change appearance based on lighting, clothing, and surroundings. This isn't perception. It's a measurable physical phenomenon driven by intermediate melanin levels and traces of lipochrome that respond differently to varying light conditions. One moment they look green, the next golden brown, then back to amber. This constant shifting reflects evolutionary versatility. Sitting between light and dark on the melanin spectrum, hazel eyes are equipped for mixed environments: sun, shade, changing seasons, and variable climates. About 5% of the global population has hazel eyes, with higher concentrations in people of European and Middle Eastern descent. Genetically, they represent a blend rather than a single clear trait. Two people with hazel eyes can have completely different color distributions. One might show more green with brown spots, another more brown with green rings. This unpredictability has made hazel eyes seem mysterious and emotionally expressive throughout history. Amber eyes are often confused with light brown or hazel, but they're distinct. Found in less than 5% of people, amber eyes contain high levels of lipochrome with very little melanin, resulting in a solid golden or copper-colored iris that doesn't shift with lighting. Unlike hazel, which constantly changes, amber stays richly golden under all conditions. This stable coloration is also seen in predatory animals like wolves, owls, and eagles. Some researchers suggest that humans subconsciously associate amber eyes with alertness and confidence, traits linked to predators in nature. Whether this gives any social advantage is unclear, but the visual impact is undeniable. Amber eyes are striking and memorable. Genetically, amber eyes appear most often in individuals of Southern European, Asian, or South American descent, though they can occur in any population with the right combination of genes controlling melanin and lipochrome production. Now let's address black eyes. True black eyes don't exist. What looks black is actually an extreme concentration of dark brown melanin so dense that the iris appears completely black. This saturation makes black eyes the most effective at absorbing light, offering maximum protection from UV radiation and glare. In equatorial regions where sun exposure is constant and intense, black eyes provide a clear survival advantage. Research confirms that darker eyes filter harsh light more effectively and remain visually stable in all conditions. Unlike lighter eyes that scatter or reflect light, black eyes absorb nearly everything, creating a deep, flat appearance that minimizes eye strain and may significantly reduce the risk of UV-related damage over a lifetime. Culturally, black eyes have been linked to themes of mystery and strength. The dense melanin makes it harder to see pupil dilation, which normally signals emotional changes. This can make emotional expression harder to read, leading to perceptions of inscrutability or emotional control. Finally, heterochromia. This is the condition where someone has two differently colored eyes or noticeable color variations within a single iris. It affects less than 1% of the population. In most people, melanin distributes evenly across both eyes during development. Heterochromia occurs when that symmetry is disrupted, usually due to minor genetic mutations, mosaicism, or localized developmental changes. Historically, heterochromatic eyes have been seen as signs of duality, supernatural connection, or divine favor in various cultures, likely because they break the visual symmetry we subconsciously expect in human faces. So what does your eye color actually say about you? It says where your ancestors lived. It says what environmental pressures they faced. It says whether they needed maximum UV protection or maximum light sensitivity. It reveals chapters of human migration, adaptation, and survival compressed into a single inherited trait. Brown eyes tell the story of equatorial survival under relentless sun. Blue eyes trace back to a single mutation that spread through Ice Age Europe. Green eyes reveal genetic complexity and adaptive flexibility. Hazel eyes show versatility across changing environments. Amber eyes reflect stable pigment chemistry found across diverse populations. Black eyes demonstrate maximum melanin saturation for extreme UV defense. And heterochromia reminds us that development doesn't always follow symmetry. Your eye color isn't random. It's the result of thousands of years of evolutionary experimentation, environmental filtering, and genetic inheritance. Every time you look in the mirror, you're seeing a biological record of where you came from and what your ancestors endured to get you here. That's not just genetics. That's history written in your DNA and displayed in your eyes.